Tonight, as you drift asleep, we'll explore the wonders of the solar system, travelling from Earth to the Sun, before slingshotting through the solar system, visiting the planets and moons, before passing through the Kuiper Belt and out beyond the Oort cloud as the sun's light fades into the distance. So take a moment to close your eyes and have a sense of relaxing back into the coziest chair with the book of today's topic. And as you open that book, you can drift into the most pleasant reverie. And the early morning air is calm and cool as the sun's light creeps up over the horizon, bathing the sky with warm colours, seeming to almost be wiping away the fading darkness of night. Rising gently above the horizon, shortly before the sun, is the bright light of Venus. Moments later, a column of light erupts into the atmosphere, illuminating the evaporating mist. Before the first intense, bright sparkles of light begin dancing through the tree line as the sun pulls itself up over the land and into view. And as you look on in awe at the beauty of the view, you think about the probe you'll be involved in launching later today. You make your journey to the launch pad at Cape Canaveral. You can see the rocket towering overhead. You head to your control station and begin the checks before launch. Different staff members have their own checks to make, one confirming the weather's holding, one checking fuel, another checking structural signals. Eventually, the countdown clock shifts. Launch is approaching. Everyone quietens down as they focus on their individual tasks. The clock reaches the last minute, then the last 30 seconds. As 10 shows on the screen, the numbers turn red. 9, 8. Hyperfocus begins to set in. Time between each number seems to stretch, almost as if each number grinds to a halt, just for a moment longer than expected. 7, 6, 5. The first sounds can be heard from the rocket. An intense fireball erupts from the base of the rocket as excess hydrogen is vented, causing a controlled singeing of the orange foam insulation. 4, 3, 2, 1, liftoff. Sparks flare under the rocket. Clouds bellow from the base of the rocket. The ground rumbles with a deep growl. The 150 decibel sound can be felt deep within your body. At first, it looks like the rocket is barely moving, despite over 2 million pounds of thrust pressing down on the Earth. Then, the rocket begins to rise. The deep, guttural roar transitions into a rhythmic, crackling, tearing sound as the rocket pushes through the thick, lower atmosphere. 80 seconds after launch, the rocket is already travelling faster than the speed of sound, over Mach 1, at nearly 770 miles an hour. A few seconds later, and the rocket is experiencing maximum aerodynamic stress, known as Max Q. Almost 4 minutes after launch, and the booster rockets quieten down and separate, making their journey back down to Earth as the main rocket accelerates from 6,300 miles an hour. Just over 5.5 minutes in, with the rocket now travelling at about 15,000 miles an hour, the first stage completes its burn and goes quiet as it separates and falls away. About 6 minutes in, and the nose cone splits, falling away, exposing the probe to space, while the second stage begins its first burn. After 10.5 long minutes, the second stage's first burn ends, having propelled the craft to 17,500 miles per hour. With the probe now in orbit around the Earth, at the right point in its orbit, the second stage begins a 14-minute second burn to propel the probe out of Earth's orbit, heading in the opposite direction as the Earth's orbit to lose Earth's orbital speed. When the second stage completes its job, it falls away as the probe travels at 25,000 miles an hour, and the third stage kicks in, propelling the probe even faster in the opposite direction to the Earth, increasing the probe's speed to 33,000 miles an hour. The probe needs to be travelling backwards relative to the Earth at approaching 67,000 miles an hour, so that it effectively almost comes to a halt in space, causing it to plummet towards the Sun. All of the planets are falling towards the Sun, but they're moving fast enough sideways that they keep missing the Sun. If you remove that sideways movement, you can fall straight down. As the third stage falls away, a fourth stage is revealed which consists of a large cylinder containing fuel and 3 30-meter wide mirrors just a few atoms thick, which stretch out like parachutes out of the side of the cylinder, reflecting sunlight onto 3 black body absorbers in the sides of the cylinder. These are small pinprick-sized lenses where the focused sunlight enters but can't leave. This heats the internal walls, which in turn is used to superheat liquid hydrogen to over 3000 degrees Kelvin. This superheated gas expands out of a nozzle out of the back of this 4th stage, accelerating the craft to 60,000 miles per hour, plunging the craft into a fall which will graze the sun's photosphere. As the craft begins its 65-day dive towards the sun, it temporarily shuts down the 4th stage, travelling silently inward as the looming sun appears to grow in size, while potential energy is turned into kinetic energy, dramatically accelerating the probe. The sun is about 83 million miles from Earth and 865,000 miles in diameter. Looking at the sun in different wavelengths and different filters reveals different details. From visible light, where you can perhaps notice a relatively smooth surface with areas that look dark by comparison, being the sunspots, through to noticing brighter patches and convection cells, to viewing the sun with a hydrogen alpha filter, where you can see features stretching off of the sun, curling back onto the sun and erupting out into space like filaments prominences, which are giant loops of plasma stretching out into space and solar flares. In ultraviolet frequencies, perhaps you notice the glow around the sun and large loops of plasma or magnetic arcs or coronal loops. Once you view the sun in different frequencies, it stops looking like a static, glowing ball which perhaps has some dark spots on it. Instead, becoming a writhing, bubbling cauldron of hot plasma and magnetic fields. By the time the probe grazes the sun's surface, the photosphere, it's travelling at over 400,000 miles per hour. Just as the probe is reaching its closest approach to the sun, the 4th stage fires back up for one last burst, with the probe performing an Oort burn. The high velocity at this point makes the fuel burn much more efficient, resulting in a massive boost to the final escape speed, accelerating the probe to 500,000 miles per hour. As the burn ends and the probe finishes its swing around the sun, the 4th stage and other casing elements are jettisoned, revealing the probe itself, a tiny coin-sized camera and laser communication system in the heart of a 50-meter wide solar sail, just a couple of atoms thick, which unfurls to take advantage of the high levels of solar radiation. Just 4 million miles from the sun, The radiation is about 500 times stronger than it is on Earth. The solar sail prevents the tiny probe from slowing down as it climbs out of the sun's gravity well. As the probe rapidly accelerates away from the sun, you see Mercury, a small, heavily cratered planet that looks a lot like the moon that you're familiar with seeing in Earth's sky. And it's only slightly larger. Mercury consists of a large iron core. It doesn't have any rings or moons. If you were on Mercury, the sun would appear 3 times larger in the sky and be 7 times brighter. You might think that Mercury is always hot, but because there's no atmosphere, temperatures go from one extreme to the other. From 430 degrees C during daytime, down to minus 180 degrees C at night. Mercury takes just 88 Earth days to nip around the sun. And perhaps surprising to some is the fact that despite the high temperatures on Mercury, there's water ice hiding within craters when the sunlight can't reach. As the probe continues to accelerate away from the sun, it arrives at Venus within about 5 days. Venus has some strange properties. It's a lot like Earth in size, yet its surface is hot enough to melt lead. And the atmosphere is like a planet-wide, thick, milky cloud, crushing the surface with a pressure of about 92 times that which you find on Earth. The planet spins incredibly slowly, with one day lasting 243 Earth days, which is longer than 1 year, which is only 225 Earth days. If you could see the sun from the surface of Venus, it would appear to rise very slowly in the west and set 243 days later in the east. Despite the extreme heat and pressure and clouds of sulfuric acid, there is a Goldilocks zone about 30 miles above the surface where temperatures are about 30 to 70 degrees centigrade and pressures are about the same as on Earth. Wind speeds at these altitudes are over 200 miles per hour, but if there is life on Venus, this is likely where it could be. It only takes 2 days from Venus for the probe to be passing by Earth again. Just as the probe is reaching 750,000 miles per hour. Seeing Earth can evoke many feelings. It's the only place that all the life we know, including ourselves, can survive unaided. Looking down at the marble of a planet, it can be awe-inspiring, knowing that everyone who has ever lived and who currently lives, every being that we know of, and perhaps many species we don't know of, every plant, animal, microbe, fungi and more, lives on that one ball in the vast emptiness of space, Perhaps something else is out there, but nowhere close to this one lone planet is anywhere near the level of complexity of life in this oasis in the darkness. There's a finely tuned balance of elements, processes and interactions, keeping this one small haven habitable. The Earth is unusual in our solar system for the size of its moon relative to the planet. The moon doesn't orbit around the centre of the Earth. The moon's so large, the Earth and moon are orbiting around a shared centre of mass, about 1,050 miles beneath the surface of the Earth. All bodies orbit around their shared centre of mass. However, for large objects like the Earth and Moon, the distance from the centre of the main object can be significant. It doesn't take long for the probe to pass the Earth and continue its journey towards Mars, passing Mars just 3 days after the Earth. From space, Mars looks calm and quiet, like a dry, cold, reddish desert world. It has a thin atmosphere, but isn't totally still. It has dust storms which can sometimes wrap around the planet like a shroud. Particles rub together and can become static, sticking to landers on the surface and causing flashes of lightning. There are also Marsquakes, although these are quite small. The thin atmosphere also means that there is very little resistance to meteors, with meteorites frequently finding their way to the surface, with little atmosphere to burn up in, and the resulting impact being felt as quakes on the planet. One day on Mars would feel very familiar to someone from Earth at 24.6 hours. However, a Martian year lasts almost twice as long as on Earth, at 687 Earth days. Mars has 2 small moons, Phobos and Deimos, with Phobos gradually spiralling inward towards the surface. Both moons are thought to be captured asteroids, and Phobos may well tear apart as it continues its descent, which could break apart and spread out into debris rings around the planet, giving Mars at least one ring for a time, although it could be shaped and influenced by Deimos into more than one ring. Or it could survive a little longer and tear apart at a lower altitude, with the parts impacting Mars. This likely won't happen for another 30 to 40 million years. Based on probes sent to Mars, it's thought that Mars was probably a much more hospitable place for life, with flowing water on the surface. There are signs that organic compounds have existed on Mars in the past, and possibly even microbial life of some kind. An exciting question is whether life originated on Mars due to potentially being able to get an earlier start than on Earth, and then hardy bacteria found its way to Earth following impacts on Mars, or whether the opposite could be true, that life started on Earth and spread to Mars. Or perhaps the most exciting option, maybe life started independently on Mars and Earth. Discovering 2 locations where life started in the same solar system would hint at life being an almost inevitable outcome given a period of suitable, stable conditions, meaning the universe is likely teeming with life. After the probe leaves Mars, there's a longer journey to Jupiter. It takes about 20 days to get from Mars to Jupiter, passing through the asteroid belt, which is an area of millions of rocky bodies, thought to largely be leftovers from the formation of the planets, and material unable to form into a planet due to Jupiter's gravitational influence. There's less mass in the asteroid belt than the mass of the Earth's moon. The probe has now been travelling for about 30 days since it slingshotted around the Sun. Jupiter is the most important planet for the probe. At these speeds, none of the other planets are really large enough to benefit from flybys for gravity assists or course corrections. But Jupiter is massive, 11 times wider than the Earth. You could fit 1,000 Earths inside Jupiter, it's so large. The composition of Jupiter is similar to the composition of stars. However, Jupiter isn't massive enough to ignite and become a star. Jupiter spins faster than any of the other planets. A day on Jupiter lasts just 9.9 hours, and it takes 12 Earth years to orbit the Sun. Jupiter has swirling bands of clouds and storms wrapped around its body, with the bands flowing in opposite directions. There's a famous storm which has been observed to have persisted for hundreds of years, known as the Great Red Spot. It's an anticyclonic storm larger than the Earth. It's probably unsurprising, given the planet's size, that Jupiter has at least 95 moons. Io is a volcanic moon like hell in space, with volcanoes erupting lava miles above the planet. Ganymede is the largest moon in the solar system, being so large, if it had its own orbit, it could easily be treated as a planet. It's larger than Mercury, and Europa is thought to be wrapped in an icy crust hiding an ocean. Out here, so far from the Sun, it would be expected to be a quiet, inactive place. But the tidal forces of Jupiter on the moons gives those moons energy, and where there's energy and water, there's potential for life as we know it. If it turns out that life potentially springs up anywhere when the conditions are suitable for long enough, then it may not just be planets which harbour life, but moons as well. Perhaps a moon like Europa has life in its oceans. There is also perhaps water on Ganymede and Callisto, although these are thought less likely candidates in any search for life. A little known fact is that Jupiter has rings. They're faint and largely composed of dark dust particles. On flying past Jupiter, the probe grabs a small gravity assist and course correction to continue on to Saturn, reaching Saturn just 23 days after leaving Jupiter. The first thing which stands out as the probe approaches Saturn is its distinctive rings. Saturn's days are a little longer than Jupiter's, at a little over 10.5 hours, with its year being a little over 29 Earth years. Saturn has a staggering number of moons, with 146 moons confirmed, and some of those moons are incredibly interesting. The rings are shaped with details, gaps and waves, with moons working like shepherds to herd the rocks, ice and dust into a kaleidoscope of formations. The rings extend about 175,000 miles from the planet. Saturn is unusual among the planets for having a density so low that if you could fit it into a large enough bowl of water, it would float. Its atmosphere doesn't look as beautiful as Jupiter's, but it does contain bands of clouds and storms, but they're shades of yellows, browns and greys. When passing near Saturn's North Pole, it's possible to see the curious hexagonal jet streams circling the top of the planet. Saturn has two very interesting moons, Enceladus, which is a small icy moon that has a crust of ice over a global ocean of liquid water. The moon's south pole features long fractures called tiger stripes, where jets of water vapor, ice grains and organic molecules vent directly into space. These plumes feed one of Saturn's rings and have been flown through by spacecraft. The Cassini spacecraft flew through a plume detecting salts, organic compounds and molecular hydrogen, strongly suggesting there could be hydrothermal activity on the ocean floor, similar to deep-sea vents on Earth, a location it's thought life on Earth might have started. This activity is from the gravitational stresses on the Moon from its interaction with Saturn. An exciting thing about Enceladus compared to Europa is that with Europa, we would have to find a way to get beneath the ice, whereas here on Enceladus, the ocean is spraying into space through cracks in the surface. The other interesting moon is Titan. Titan has the most Earth-like feel to it of anywhere in the solar system. It has clouds, liquid and land. However, it's a very alien place, so if any life was found here, it would demonstrate that life is possible with very different chemistry to here on Earth. Titan has a thick atmosphere which consists mostly of nitrogen, with methane and complex organic molecules. Its surface temperature is minus 179 degrees C, so far too cold for liquid water. Water ice on Titan acts like rocks on Earth. On Titan, methane and ethane behave the way water behaves on Earth. Titan has lakes and seas and rivers. It has rain which falls in slow, large drops, clouds and seasons, all based on hydrocarbons instead of water. Its surface is coated with dunes of organic material and smooth plains shaped by flowing liquids. There may be deep subsurface ocean of liquid water, likely mixed with ammonia to keep it from freezing solid. It's a truly fascinating place with complex organic chemistry, the building blocks of life forming naturally in its atmosphere. The environment has potentially been active and stable for billions of years, so If life can form with the chemistry available on Titan, it may well have had time to do so, and would be very different from life as we know it. Passing Saturn, it takes 50 days to reach Uranus. The inner planets were rocky worlds. Jupiter and Saturn were both gas giants. Uranus is classified as an ice giant. Its interior contains water, ammonia and methane ices mixed with rock, all tucked beneath a hydrogen-helium atmosphere. One day on Uranus is about 17 hours, with a year taking 84 Earth years. Uranus is unusual among the planets in that it's tilted about 98 degrees, so it's essentially rotating on its side. This means the poles experience about 42 years of continuous sunlight, followed by about 42 years of darkness. It isn't known why it has this extreme tilt. Perhaps in the early formation of the solar system, when things were more chaotic, one or more Earth-sized planets or protoplanets struck Uranus. Perhaps at shallow angles leading to the tilt. There are issues with most current theories in that there are no remnants, and the internal temperature of Uranus is much colder than would be expected if it has received one or more significant impacts of the scale that could topple it onto its side. Uranus has a very calm blue-green colour. The atmosphere is cold and windy, with wind speeds up to 560 miles an hour. It's also the coldest planet in the solar system, with minimum temperatures around minus 224 degrees C. Although faint, Uranus has narrow, dark rings composed of ice and rock, and it has 27 known moons. After leaving Uranus, it takes another 56 days to reach Neptune. The probe has now been approaching 6 months since it started its journey. Neptune was quite a recently discovered planet. It was discovered in 1846 and was the first planet to be discovered through mathematical prediction rather than direct observation alone. Its position was predicted based on irregularities with Uranus's orbit, and then observations were made, finding the planet where it was expected to be. Like Uranus, Neptune is an ice giant. A day on Neptune lasts about 16 hours, and a year takes 165 Earth years. As Neptune comes into view, one striking feature is its deep blue colour. The planet experiences the strongest planetary winds in the solar system, reaching speeds of over 1,200 miles per hour. With massive storms like Jupiter's Great Red Spot, but these storms are dark vortices passing across the planet. Like Uranus, Neptune has a faint ring system of dust and ice, with these rings being more clumpy rather than uniform. There are 14 known moons around Neptune, with one moon, Triton, circling the planet in the opposite direction to everything else, thought to have perhaps been captured at some point. Neptune is the last planet currently known in the solar system. There are hints that another planet could or did reside in the outer reaches of the solar system, but this has yet to be confirmed. Beyond Neptune, the probe makes the lonely journey into the Kuiper Belt, which is made of millions of icy bodies, vast distances apart, including dwarf planets like Pluto and Eris. Many short-period comets are thought to have started their life in this area of space. The Kuiper Belt is thought to be a flattened disk aligning with the plane of the planets. It stretches from about 30 times the distance of the Earth to the Sun, up to about 50 times the distance of the Earth to the Sun. About a year and a half from leaving Neptune, the probe finally reaches the heliopause. This is the boundary where the solar wind crashes into interstellar space. At a distance of about 120 times the distance from the Earth to the Sun. It's a turbulent location. Passing through this location into interstellar space means the probe has passed outside of the Sun's protective plasma bubble into an environment dominated by interstellar particles and magnetic fields. The Sun's influence doesn't stop there, though. Its gravity is still holding objects in orbit. The probe has to travel through the dark, cold silence of space to a distance of around 2,000 times the distance between the Earth and the Sun. A journey which could take the probe 300 years just to reach the inner edge of the Oort cloud, a distant spherical halo of icy objects which surrounds the solar system, which has never directly been observed, but whose existence is inferred from the orbits of long-period comets. Although it's called a cloud, like with the asteroid belt and the Kuiper Belt, it's a very sparse location, in fact, likely significantly more sparse than either of those locations. The Oort cloud is thought to extend perhaps 100,000 times the distance from the Earth to the Sun, which is a distance of over 1.5 light years, which is approaching half the distance to the nearest star. For the probe to pass this distance would be a very long and lonely journey, taking thousands of years. Before the probe makes this final leg of its journey, it faces its camera back towards the planets and the Sun, uses optical features to block and reduce the Sun's light in the image to better expose for the planets, and takes a long exposure photograph of the plane of the solar system. This is the last image you receive, about a year after the probe launched, before the probe says goodnight and puts itself to sleep as it drifts through the endless night, and with a wealth of data and a deep sense of satisfaction and success, you go home from the last time receiving information from the probe. And as you close the pages on this topic, you can settle down so comfortably and peacefully in bed. And as Your unconscious now absorbs this learning from today. You can drift so deeply and comfortably asleep with each breath that you take, sleeping perfectly and soundly, asleep all night long.